What's up, guys? Juan here. Today we are diving into the second and final part of that dual VCA ADSR combo last time, which, by the way, I've renamed that. So stay tuned to the end of the video to find out what the new name is. If you missed the first part, check the links in the description and be sure to, give that a watch so you can get a nice recap. Today, we're not just gonna wrap up, but I'm actually gonna be reflecting on the journey. So today's video is gonna be a little bit different. I'm also gonna use this opportunity to conduct somewhat of an informal retrospective on this project. If you recall, this project was combining two circuits, an attack, decay, sustain, release circuit, and then a VCA that was based out of the LM13700. And then we made some modifications to it to add additional outputs and allow for additional inputs, etc., etc., etc. Yeah. So if you want to recap, go watch that video. It'll tell you all that stuff. For this project, I wanted to try a few things a little bit differently. Remember, I talked about the sliders I really wanted, and let me bring up this. So these are the potentiometers that I ordered, and I really wanted these because I was really curious about this shape. I want to see how well they perform with time and a lot of use. I couldn't wrap up the last project because I didn't have footprints for them, so I had to make some custom footprints for this. The other thing is, and let me bring KitKat back here again. Normally when I make my boards, my panels, I am basically I'm working on the edge cuts, and I am creating, like holes like this with shapes, right? Where then if once you build it, you see that becomes a hole. But the problem is that I find myself doing the same work over and over and over again every time, and it's still time consuming. So this time I wanted to try something different. Previously, I had already begun to use this technique, which was to create footprints for the holes. These right here are the mounting holes, and those were the first ones that I had done. I did this previously, and it worked really well. So I thought, you know what? Let's do the same thing with the holes that are needed for the components. And so I went ahead and I created all of these, even for the sliders. These are actual components, right? And I edit it, and then I can see this is an actual footprint, right? And because it's already been done with even the design elements that I want, all I have to do is just place them, and they just work, which is lovely. Because this circuit needs some adjustment, right? We need to have a 5 volts reference for one of the inversions that we're doing. Getting a 5 volt reference is critical. So I added a couple of test point holes in here just to make sure that is there. Now, I only added one for 5 volts. I did not add one for ground, and I will talk about this in a bit. The last thing that I really wanted to try out with this build here was more on this sheet arrangement here. So because we were working with multiple circuits, each one of those circuits, like this one, is already a pretty full sheet, right? And if I had added the other circuit in here, then that probably would have gotten really messy really quickly. So I used the schematic hierarchy here in order to break this up. So we got the parts, put the module together, and in fact, let me show the finished product here. Here's the finished product, and I have to say it looks freaking fantastic, right? Yeah, big shout out for PCBWay for contributing these boards to the project. They are this project's sponsor, and they provide me with all of the circuit boards that I've been using for this project. I was for this project, I was trying the matte finish on this, and I have to say it really does look quite amazing. It's really good, very very smart looking, and yeah, I will definitely do it again. Yeah, really quite happy with the quality of these circuit boards. So definitely check them out. Circuit boards is not the only thing they do as well, so definitely go check out what all the different things that they do, because they'll do like milling, and I think they have like a 3D printing service as well. They'll even mount your components on your SMD, boards if you provide them the parts, I think. So yeah, go check them out. Unfortunately, everything was not without issues. So, in fact, I had to kind of monkey patch this quite a bit. Right here, you can see there's some wires. And this brings me actually to my first point of the sort of retrospective we're going to talk about. I ran into a few issues. Some of them were nothing too drastic, but this particular one was a big one. Let me just talk about it and get it out of the way. I decided to break this up into sub modules, right? Like the sub sheets. This was a decision that I made as I was working on this. Well, I'm still not 100% sure this is the exact layout or format that I want to follow, but I was trying new things, right? And you have to try new things. You have to, because how do you know if something works unless you try it? Progress is not made without fault. It's an inevitable piece of learning. Failure is part of that, right? And so, we're going to experience some hurdles along the way. And that's okay, right? That's how we learn. So what happened here is that I started routing all of this stuff, and I neglected to, I was very careful, and I missed 2 pins. So 2 pins were reversed, the discharge one and this guy right here. What ended up happening is that this envelope here, this path, so this is one complete signal path, with the envelope affecting this VCA, and then this envelope affects this VCA. And so what happened was that I could only get the attack and decay to work, but sustain and release did not work at all. And it was because those two were flipped. So in order to fix it, I had to cut some traces on the board and then reroute the wires. So the traces had to be cut here, that one, and right here. And then I had to reroute. So I've already fixed this on these, by the way. I'm still wrapping a few little issues in there. So once the link goes into the description or my blog, you know that all the issues have been resolved. I'm not going to post anything up there until I've solved them. So you guys don't have to go through the same problems that I did. Oh yeah, there was one other major problem that I ran into. So this footprint here, this is not a footprint I made myself. It's also not a footprint that comes with KiCad. But I've always had problems with this particular one and the switches that I use, in which these holes are never big enough. So this one was slightly different. Instead of using round holes, it had oval holes, and it actually has a 3D model of it, which is why I picked it. I wanted to see that 3D model in it, right? I'm talking about that. The problem with this is, let me show you. It doesn't, the footprint is wrong, and I haven't fixed it yet. But as you can see, here, there is no copper exposed here. This is being covered by that mask, right? So you can't solder onto that. So I had to scrape it in order to expose the copper to be able to place the components. It was time consuming. It was, but it was not a deal breaker. The next issue that I encountered was with this button here. So these buttons I got also from AliExpress, and they're these guys right here, the TSH002, which has this LED pins on the wider part of the button pins, right here. This is not to be confused with the H004, which has the pins on the narrow side. So don't get those if you plan to do this, right? Get these ones. These are the ones that I use. So the problem here is there really is no data sheet for this. The only information is just what I found on AliExpress, and this information is wrong. So over here, this pin number 5, which is this one, it claims that that is the anode, but in reality, that is the cathode. And so I ended up soldering this backwards. If you get this exact part, chances are the long pin is going to be the one that's going into the cathode side, right? And I marked it on the PCB as K. And last problem that I ran into here is, so I made all of these footprints for this, right? And these were perfect. I had no issues with that. They were exactly the right size. These were a little tight, but still fit, without having to be forced or anything. They're just really snug. Probably will make this a little bit wider just to give me some more room. Definitely, these holes will only fit potentiometers that don't screw onto the panel, okay? Which are the ones that I used. Like these guys. These, okay. But if you're screwing them into the panel, they won't fit. You'll have to change that. But these guys are the jacks, and they were too small. So I had to drill through. And the reason why they were too small was because I used pads for this. So there is solder pad, in these right here, right? And what I didn't account for, even though I allowed for an extra clearance for this, because I thought that this was going to add more thickness to this, it wasn't enough. So I had to cut through this to be able to fit those jacks. Now, it doesn't really matter because the jacks obviously have some nuts to secure them. These guys right there, right? So it covers up any imperfection. So you can't even tell that it was modified. Let's do some reflection here. I've already addressed all the issues, and there's a couple of them that I'm still working on, but will be addressed. So no action items here. But we did learn some lessons. So the first one, okay, on the potentiometers that I use. So I really do like this. I have to say, I like the concept. I think that the reason, the reason why I was so interested in these is because of the shape. My gut feeling says that these will probably last a little longer. However, they are a pain in the behind to place and mount, especially how I wanted to use them. I'm sure that if I keep using them, it will become easier, but this forced me to screw and unscrew and rescrew a lot of the components on the in here as I was doing it, that it ended up taking way longer than if I had just used the normal potentiometers. So will I use them again? I don't know. Maybe, most likely not. Okay, the next thing, so using the footprint for those holes for here was definitely a win. Yeah, I highly recommend it. So if you're making front panels, spend the time, make some footprints for your holes in your panels. You'll save so much time by doing this in the long run. Test point was a great idea. I just really wish I had added a ground point. So in the future, that's going to include a test point for ground as well. And then lastly, the idea to split the project up into multiple sheets, I think was great in theory, but poor in execution. If I do like the idea of this, and if I do it again, it's probably not going to be separated like I did it here, but instead I likely will create this more into like functional components. The way that this is right now is, I think it's okay, but I think it could be better. So we'll keep iterating through this. If you're gonna make this, there's a few things you should know. The first thing is, you're gonna have to calibrate it, and you have to test it, right? So to calibrate it, that's what the test point is for. So right here, so what you're gonna do is, see this reference adjust, you're gonna turn that until when you probe that pin right there. So you'll put your multimeter probe in there and set it to voltage, and then find a test ground, obviously, for your comm. But you're gonna turn that until that reaches to exactly 5 volts. Once that is exactly 5 volts, you're gonna make sure you're plugged in and turned on and all that stuff. Then that piece is done. The offset adjust, there's 2 ways you can do it. If you want to be really accurate, then use an oscilloscope. And what you can do is you can use two probes in an oscilloscope. One of them, plug it to the envelope output, not the inverted one, but this one. And you want that to be at 0 volts or as close to 0. It's not going to be exactly 0 because there is a bit of adjustment that needs to be done in order to fully close the envelope when it's supposed to be closed. So what I do is I also put another probe on the audio output, and I feed a reference signal in the audio input and the audio output right here. That's gate and retrigger. So I feed a signal, something like a triangle wave in here from my modular. So I had one and I plugged it in here, and it was 10 volts peak to peak. And so then I observe what's happening out here. If everything is closed and nothing is opening, there should be no audio coming out. But if I see a wave in there, that means that it needs adjustment. And so what we do is we look at the offset for that particular ADSR, right? There's 2, one on the top, one on the bottom. And then first you're gonna turn it all the way clockwise until you get to that 0 or close to 0. And then you're slowly gonna move it back until you have no audio bleeding, okay? So like I said, oscilloscope is the best way to go, but you can do it without. If you don't have an oscilloscope, just all the way and then bring it back. You want to do it just until you don't hear anything. If you go too much, then you're going to be affecting the amplitude of the envelope, which is, going to be affecting the performance of the VCA anyway. So, but you can do it that way. That brings me into a point in here. I used these guys right there, these trim pots, which I got this out of a surplus store, and I can't find these anywhere else. So if you choose to make this, I think these right here will probably work, except that these ones don't seem to have the ability to turn the wiper from the bottom, which is what I'm doing here. I'm turning it. I'm actually getting from the inside in here because they're mounted on the inside. So what you can do is, if you get those, the pinout's going to be the same. So basically that middle pin is always going to be the wiper. So what you can do is just mount them from the top. it just means that it's going to be reversed. All that it's going to mean is instead of turning clockwise, we're going to turn counterclockwise. So it'll still work. Okay? So yeah, there you have it. That is the dual VCA ADSR module from start to finish. And by the way, this is now called Meow Out Loud. So huge thanks for being a part of this ride. If you got questions, drop me a line in the comments. Don't forget to hit that like button and all that stuff. And tell all your friends about what we're doing here. And yeah, till next time, just stay creative, stay productive, make some tunes. And in fact, enough talk. Let's go jam. Bye.
Boop.